In this video, we are going to look at how to sketch a shifted cosine graph using the 3 steps to sketch advanced method. So we're going to look at y equals negative cosine of 1/2 x plus pi over 2 plus 2. So just off the bat, we can tell that this is a reasonably complex cosine equation. We can see that we have some shifts going on. We have the plus pi over 2 term here and the plus 2. Okay, so the pi over 2 we know is going to be part of a phase shift, and the plus 2 is showing a vertical shift up 2. And before we jump in to our method, let's go ahead and factor out our b term so that we can clearly see our phase shift, which we know is actually the c term divided by the b term. So from here on out, we'll work with the equation y equals negative cosine. We'll pull out that 1/2 and we're left with x plus pi and then still plus 2. So distribute that 1/2 through, you'll see that this is the same equation, but now we can clearly see that phase shift here, the x plus pi. So that's telling us our phase shift is going to be left by pi units. So we'll shift our whole function to the left. And this is a pretty common mistake. The reason I like to go ahead and factor out the b is because looking at the equation, we'll say, oh, look, there's the phase shift. It's left pi. Whereas if we left it in its original form, you may be tempted to say that pi over 2 is the phase shift, which is not true at all. You would have to divide pi over 2 by 1/2. That would give you the phase shift of pi. All right, so just setting ourselves up for success here, let's jump into the method. Okay, so we have our method outline on the left, so we can keep track of everything. And here is our equation with that b term already factored out. Okay, again, this is a shifted cosine equation. Easy to see that we have those shifts. It's in that form a cosine b, and then we factored out the x minus c part. The bx minus c turns into b parentheses x minus c over b, and that's to show that the c over b is our phase shift. Okay, so if you like to leave it alone, you can, but just to prevent that temptation, we have it written out like this so we can clearly see the phase shift and we know we're going to get it right. All right, let's jump in. So step 1 is to find the essential information and really get it organized. This is the meat of the method. So we'll start by identifying a. A is the coefficient in front of cosine. In this case, it's a -1. Okay, so the absolute value of a tells us what our amplitude is for our graph. So our amplitude is just 1. It's the same amplitude as our parent graph, y equals cosine x. Now the negative is something I like to go ahead and put a star near step 2 or a circle or something that's going to alert me to, hey, there's a negative in front of my equation. So we know our graph is going to be reflected over the x-axis. It's that vertical reflection. So just put yourself a reminder. You are way less likely to miss it if you have something like that just labeled over by step 2. All right, so that's A. Now B, we see, is the coefficient of x. It's 1/2. Okay. B tells us, firstly, how many cycles of our graph will happen between 0 and 2 pi. So in this case, we'll have half a cycle in that space. And it also helps us find the period. So we calculate that for cosine, doing 2 pi divided by b. So since we're dividing by a fraction, let's multiply by the reciprocal. All right, our period is going to be 4 pi. That's the length of one horizontal cycle. That should always make sense with what b is. So if half a cycle happens, like b says, between 0 and 2 pi, it makes sense that a full cycle would happen in double that, so in 4 pi. All right, now we can move into labeling our axes, and we're going to do this very intentionally, specifically for our horizontal axis. We are going to design it so that each of our key points in step 2 for getting our cosine curve going will align with our horizontal tick marks. It makes for just a really nice, neat graph. So to do this, all we have to do is take our period and divide by 4. So for this, our period's 4 pi, so 4 pi divided by 4 is just pi. Easy enough. And then for our vertical scale, this one is less of a big deal. 1 usually does the trick. So let's go ahead and label our axes. So we'll be counting by pi for our horizontal axis. So 1 pi, 2 pi, 3 pi. It's almost just like counting like you probably did in kindergarten, just with pi tacked on. All right, got that. Let's go in the other direction. All right, hopefully this stays readable. All right, so we're getting this whole thing labeled. Hopefully yours looks nice and neat. And now we can do the vertical, also counting by 1s. So not quite the same, but the same kind of idea. So we have our axes labeled. Now we can identify our shifts and then we'll be ready to start graphing. So because we went ahead and did that factoring out of the b, we can clearly look and see our phase shift. Okay, the only thing you have to watch out for is that it's x plus pi. So we are going to be moving to the left because our shift is actually hidden. It's like x minus negative pi. Okay, so we are moving left pi units. Okay, and you might even write yourself a reminder, move left. Okay, and then our D is our vertical shift, and what we see is what we're going to do. We see a +2, so we will move up 2. All right, so that's our analysis done, and we can move to step 2. We'll plot the base pattern, and we have that star as our reminder here. We know we are going to be dealing with a reflected cosine graph or reflected base pattern. So our graph, and we're going to do this lightly because this is not our final graph, it's just our starting point, but it will be in a pattern of minimum, 0, maximum, 0. Okay, it's reflected. All right, we know our first point. Do this lightly or in another color. This is just our base pattern. We'll shift in the next step. But our first point will be on the y-axis, and it's going to have a y-coordinate of a. Okay, so lightly make a mark on 0, -1. Okay, our next point will happen at the first horizontal tick mark to the right, so at pi, and it's a 0 or an x-intercept. Okay, the next point will happen at 2 pi, next tick mark, and it'll be a maximum or the opposite value of a, so +1. And then at the third horizontal tick mark, 3 pi, we'll have another 0. Okay, let's close it out. We know 4 pi would be another minimum, starting the next cycle, finishing this one up. It's just nice to have there. All right, we've got our base pattern. We feel sure that we have reflected the graph as we intended. And now we can move into step 3 and apply our shifts, sketch, and repeat. So we'll be shifting these green points from our base pattern, and we can do both of these shifts at once. Okay, so work for each green point. We'll move each of them left pi units, which is just 1 grid mark horizontally, and we'll move it up 2 units, and that's 2 grid marks based on our scale. Okay, so maybe change colors or darken these points. These will be your final points. So move the point that's on the y-axis, left pi, and up 1, 2. Okay, so we moved it left and up. And we'll do that for every single point. So we move it left pi, up 2. Okay, I'll make them a little bigger so we can see. Left pi, up 2. Left pi, up 2. You should see the cosine curve maintaining its integrity, its shape. It's just that you are shifting both of these shifts at once. Left pi, up 2. All right, so you have your final points, and let's go ahead and sketch our cosine curve. Okay. Now let's repeat this for a few cycles, and I'll switch to a different color so you can see the repeated cycles. So we just are going to continue the pattern out in each direction. Okay, you can see that new midline is at y equals 2. So those were the points that were originally x-intercepts. Now we'll just call them midline points. So we'll have working right, midline point, maximum, midline point, minimum, midline point. So we have another nice cycle here. And we can work in the other direction too. So we have midline point, maximum, midline point, minimum, and so on. Okay, and you can see, maybe draw yours a little bit neater. Okay, but we have several more cycles of cosine on here. Once you have that first cycle, you are really good to go because all the other cycles are just a repetitive pattern. So it's almost like you have a stamp and you're just moving it, picking it up, moving it, picking it up, and just going for as many cycles as you need. One quick thing to just double check, I always like to do this, look at your B. We see that B is 1/2, and that means that we should have half of a cycle happening between 0 and 2 pi. So looking between 0 and 2 pi, that makes sense. That's half of a cycle of cosine. It's a little bit of a shifted half, but it is still definitely half of one cycle. That's 2 of the 4 quadrants or parts, if you like to think about it that way. All right, so this was a crazy looking cosine equation that once we really got all the pieces put together was not too difficult to graph at all. If you'd like to see some more videos that are using this method, check out the links in the video description. There are links for cosine, as well as sine and tangent, and soon to be probably a couple more as well. So good luck, keep practicing, you can do it.